What is up, everyone? Welcome to Gentlemen of the Corax. Today's going to be a really cool episode. We'll be having a marine showdown between the three periods of the Mesozoic era. Now, the Mesozoic is famous for being the era of the dinosaurs, even though we still do have dinosaurs in the Cenozoic, birds, but people sometimes forget that. But
Okay.
anyways, these are like the non-avian dinosaurs, the famous dinosaurs. They all come from the Mesozoic. And within the Mesozoic era, we have three periods. We have the first one, the oldest, which is the Triassic. And that's from around 252 to 201 million years ago. The Jurassic is the second period, which is from around 201 to around 143 million years ago. And then we have the Cretaceous, which is the last period, and that is from around 143 to 66 million years ago. We have two mass extinctions, I guess three if you count the onset going into the Triassic within the Mesozoic. We have the Permian Great Dying, which came first, which basically put the onset of the Triassic in motion. Then we have the end Triassic mass extinction, and the one that most people are familiar with is that end Cretaceous, the KPG mass extinction. So we have a really cool bookmarked era right here, and what we're going to be comparing right now is the marine fauna. We're going to be ranking which periods are from the best to worst for their marine faunas and why we think so.
What kind of criteria should we use? Should we use any criteria? Should it just be
Vibes.
lives?
I'm
Yes.
thinking vibes.
Mhm.
They can be based on diversity. They can be based on coolness, like the weird and wonderful. They could be based on size, whatever your heart desires.
Okay, I would like to present to anybody watching and listening that I am a Cretaceous researcher and I will do my very best for the Jurassic period.
Triassic, and I will also pitching the Jurassic period.
Let's go.
Okay. Let's start with the period, and then we talk about the period. We talk about things in the period
Yeah.
that we know, and then we can get to the arguing phase.
Let's go from oldest to youngest. So let's start with the
Alrighty.
Triassic.
Okay, so the Triassic is frequently seen. I'm assuming if you found this channel that you have a pretty like solid understanding of what the Triassic is. If you don't, the Triassic is the first time we actually see marine tetrapods, things with bones, things that lived on land and are moving back into the oceans. Triassic is the first time that we're actually seeing these marine tetrapods move into the ocean and diversify. And immediately, the ichthyosaurs, the first to do this, who probably originated in the Permian, turns out. Um, Within 5 million years, you get my site at Fossil Hill out in Nevada, and you have sperm whale-sized animals just 5 million years, 5 to 7 million years post Permian Triassic extinction event. So you have an enormous and the largest in the entire Mesozoic diversity in size amongst these kind of ecological guilds. But at first, diversity is very constrained. It's entirely ichthyosaurs. In the Tethys, I work out in what's the Paleo-Pacific, but in the Tethys, where every other of these kind of earlier Triassic sites are from, you have this hotbed of diversity. You have lots of different Ceratorygians, you have Placodonts, you have Tanystrophiids. Placodonts are, or so Ceratorygians are like plesiosaurs, nothosaurs, proto-plesiosaurs. We have a single Ceratorygian out in my site in Nevada. A single one made it into this giant panthalassic and paleo environment, and that's Augustosaurus. It's a little, 10-foot long proto-plesiosaur, so it's got a long neck, but not plesiosaur long yet, and its paddles still have some fingers on them, some fingies. But out in the Tethys, this kind of shallower area in the middle of Pangaea, and not in this kind of global ocean on the opposite end of Pangaea, you have this hotbed of diversity. You have the Tanystrophiids, for example, have necks that are many times the size of their lengths of the not many, but multiple times the lengths of their bodies. Um, Placodonts, which are these weird Duraphagous Sauropterygians, it's kind of like plesiosaur affinities, crunching shellfish. You have Octopodentatus. What's the name of that group? Anybody remember?
Yeah, I can see it spelled in my
I've
head.
literally found them in the field before.
You could have asked me 5 minutes ago and I would have known the answer, but since you put me on the spot, it has like
Quick, somebody
exited.
message Alexander.
It's just gone.
He would know. So, anyways, I do a lot of commercial paleontology, and since the Triassic doesn't show up on eBay at all, I know nothing about
Well, the Triassic is a cool period for chondrichthyan evolution, um, because when we look at the Paleozoic, for example, which would have been right before the Triassic, sharks, like the true sharks, really weren't much of a thing. They kind of took the back seat towards other elasmobranchs, such as coelacanths, for example, as well as some holocephalans and euchondrocephalans. So euchondrocephalans would include things like the modern day ratfish, but in the Paleozoic, you added these really large ones, such as Halicoprion, Adestus, things like that. But in the Triassic, we kind of see a faunal shift where some of the Eucelachians, which include the true sharks, but also other shark-like relatives such as hybodonts, they really kind of started holding their own within the Triassic. You had some eugenodonts still within the Triassic, but really the main chondrichthyans would have been your hybodonts and then your early true sharks. So it's a really cool fauna because some of these don't resemble anything like what we see today. Some of the chondrichthyans you have Pseudodilatius, which for some reason has teeth that look very similar to modern day squaliforms, even though they're most likely nowhere near closely related. You had these pointed and cusped upper teeth with these saw-like lower teeth that are in a row, kind of like what you'd see in a kitefin shark, Dilatius, hence where it gets its name. Um, you have some early stem sharks that we really don't know where they sit phylogenetically outside of them just being towards the base of the shark family tree. So you have some weird ones like Duffin Salaki. You have Pseudocederinus, which used to be considered to be a Triassic relative of the basking shark, Cederinus, but that's most likely again not the case now that that we're seeing that.
Right.
Um, but yeah, so outside of that, you just have some really weird sharks and shark relatives. You have hybodonts, which were also around in the Paleozoic, but this is kind of their time to shine in the Triassic. Did you wind up finding a Cole?
Yeah, thalattosaurs. Thalattosaurs is what I was trying to mention. These are like, kind of very streamlined lizard-shaped long needle snouts. Some of them have that like premaxillary kink in them. Um, those guys are all over the place, but the marine reptile diversity is high. And in terms of like the ichthyosaurs even produced a couple Durophagus members, the omphallosaurs, who's I'm texting one of my collaborators. He's working on the first complete omphallosaur skull right now for a in his prep lab. So really looking forward to seeing that. And that's the beginning of the Triassic. As the Triassic goes on, you get these kind of the coalescence of all these uh, um, traditional Mesozoic marine groups like the plesiosaurs and the more normal ichthyosaurs. The tanystrophids hang around, the thalattosaurs hang around. Diversity is really high, uh, and I think in a lot of and by the end of the Triassic, you've got as as kind of now was once kind of ichthyosaur esoterica, but is now kind of revealed to the paleosphere at large, that there are blue whale sized ichthyosaurs known from the kind of the end Triassic. So you have enormous diversity in guilds, and you have enormous diversity in terms of size ranges. And even though like it's not as kind of classic as these long-necked plesiosaurs or iconic as these long-necked plesiosaurs and the pliosaurs and the mosasaurs. I think there's this kind of proclivity to see the Triassic as just like the precursor to the cooler stuff that comes later, when really the Triassic marine assemblages are just as spectacular, unique, and wonderful as any other time in the Mesozoic.
Hmm.
Brennan, do you want to talk about ammonoids? Do you know much about ceratid ammonites?
Oh my goodness. I did all my research on the Jurassic invertebrates. I thought I'd be helping Bethany fight for the Jurassic only, but no. I'm not good with Jurassic ammonites. Only like heteromorphs from the Cretaceous and some of the Jurassic ones, like the big guys.
Hmm.
But early ammonites,
Yeah.
don't can
Well,
do.
ceratid ammonites are explode in diversity and coming out of
Mm.
the and Permian mass extinction event. Some of the specific little strata in my field site are bioclastic
Oh wow.
ammonoid
Mhm.
zones. And so a question's kind of come up around these giant ichthyosaurs from I mean, really the entire Triassic interval. We've got the ones at my site are only humpback whale size, but later on you've got stuff that are the size of whales. What's supporting these ecosystems that with these giant animals? And a lot of these kind of the thoughts going around now is that these are not fish supported ecosystems like a lot of modern ones, but they're in fact um, cephalopod supported ecosystems. And I think that this also extends into the Jurassic and some of the in certain zones and some of the Cretaceous as well. Um, that these ammonoids and then eventually belemnites and such are and then finally squid are forming the foundation of a lot of this diversity that we're seeing.
Interesting.
There is something very cool that I learned recently in geology class of all places.
Mhm.
Um,
Well,
there's
yeah,
a
I didn't learn
specific
anything there.
type of specific type. Oh yeah, sorry. No shade to geologists. There's a specific type of trackway that is mainly attributed to trilobites called Cruziana, and it's very diagnostic in its shape. It's very wide, and you get all the little legs and the gill rakers hitting the sand and making these little C patterns in a line, right? And throughout the Paleozoic, um, they when they're found, you automatically assume, okay, it's a trilobite, right? Um, so throughout this entire period of time, geologists and paleontologists say, okay, Cruziana are trilobite trackways. They're very diagnostic, and there's not really any animals that like also make them, right? So
Mhm.
they were just set with that. Okay, Cruziana are just trilobite trackways. They found Cruziana trackways in the Triassic, the lower Triassic, like right after the Permian boundary. And some geologists and paleontologists speculate that these trackways are trilobites that survived the Permian mass extinction. And I think that's very interesting because they haven't found any physical proof, like
Yeah.
trilobite bodies at the site yet, though it hasn't been sampled really well. I've seen the paper, and they do very much look identical to trilobite cruziana. Um, the site is in northern BC, and it's actually not far of a drive from my house. It's only like 7 hours.
Oh, is this in the Pardonette, or
Hmm?
or is it early Triassic?
Uh, let me pull up the paper really quick. I think I have it on tab. But it could just be a marine invertebrate with similar legs, making it either or.
That'd be pretty interesting too, honestly. Just like a similar, I love convergent evolution, just having the same body plan and
Hmm.
so distinctive. And then,
Yeah, if it was anything besides trilobites, I would say like maybe the fossil record is incomplete and these things actually did survive for longer than we think, but it's trilobites which have zero problems fossilizing.
Exactly. And you'd expect to find them at the site as well, since they're very much hard-bodied. Oh no, the ones in British Columbia are Middle Triassic.
Oh, cool.
Okay.
I'm not familiar with the name of that
Hmm.
formation. I probably should
Uh,
be.
blah blah blah. Where's the formation name? There's a PDF logo blocking the formation name. It's great. Triassic Ladinian. That's not the formation.
What it needs the stage.
Yeah, the stage.
Yeah.
It doesn't have it in the title.
Okay.
That's
It's
okay.
it's it it's Latinian. Okay. I get it
Okay.
now.
Yeah. So that's pretty neat. And I'm excited to get out there. Whether or not I find trilobites, I don't care. The trace fossils will be cool to have.
I do have a Triassic ichthyosaur question.
Let's go.
So, from the time that I did my field work for school in 2021 to now in 2025, there seems to have been just my understanding about ichthyosaur size has pivoted.
Hmm.
Definitely, there's these larger members like coming out into the fold, and you saying like why would such early like ichthyosaurs, when we look at gigantism, at least Brennan's gonna cringe in Romania for in
Craziest thing I've ever
dinosaurs,
heard.
the gigantism comes because of like their isolation in the island, and that is towards the end stages of dinosaurs like being around. Gigantism right at the beginning, why is that showing up in ichthyosaurs, gigantism
Uh,
like so early on?
so I think it's a combination of these like early Triassic oceans being kind of very productive
Very
for
productive.
some reason that we don't really understand quite yet. But also, so we have large pelagic ichthyosaurs, 20 feet or so,
Yeah.
from like a million years post PT extinction event in Spitsbergen, where I've got some of the collaborators who work at.
Yeah.
Um, and they just kind of came out and said what ichthyosaur researchers have been thinking for a while is that we should probably start categorizing ichthyosaurs as end Permian survivors and not people like things that came after and moved into the gaps created in the
Yeah.
oceans. So, but I think they were probably just could evolutionarily move into like the niche space in order to get big. They were just capable of doing so in ways that the later animals wouldn't. Um, and because like all the early big ichthyosaurs, like my Cymbospondylus shangorum from my site, 60-foot one, it's the skull that was in the big 2021 paper published by the my mentor Dr. Sander, and then Thalattoarchon, which is Cymbospondylus, this guy here.
Hmm.
That skull is taller than I am, and I am 6'2". So, and like think mosasaur proportions. So, um, bigger than any known mosasaur, or any well-known, any currently described like complete mosasaur skeleton. We also have that one's the generalist. That one's got small pointy teeth. We also have Thalattoarchon saurophagus, which is the apex predator. Um, Holotype was described in 2013. It's now at the Field Museum, big Nat Geo thing around it. Um, the mass the length estimate they gave for it was 28 feet, which was intentionally very conservative. They said, okay, this is a medium-sized ichthyosaur with a giant, huge head, because there was no kind of animal known from this time period that could even get that big. But now we've got a species of Cymbospondylus whose size, because we have almost entirely complete skeletons of Cymbospondylus, we have a very good idea of how the proportions are. Now it's a lot less kind of preposterous to claim that these ichthyosaurs got big, and the skull bones on this Thalattoarchon and this guy's teeth are not small and pointy. They are like kind of like that size right there. Heavily Zyphodon, the most like raptorial looking teeth of any known marine reptile. And again, this is 5 to 7 million years post-Permian Triassic extinction event. And we don't have the entire skull. We've only got kind of like the snouts chopped off. We have two more specimens in preparation now that one of them which I collected, Ramona, that hopefully will give us a good idea of what the skull looks like. But all those bones are the exact same size as they are in giant 60-foot Simispondyls femorum. So we have two giant ichthyosaurs, one the generalist and one the apex predator. And all this happening very, very soon into the Triassic. So the Fossil Hill member where I work out in Nevada, it outcrops in two spots in the Favorite Formation in the Augusta Mountains, which is where I do work, and then the more historical but not currently being studied. There was a guy who owns the spot that was reached out to us this year, who um, has actually he's an old geologist, has actually got some really cool material there that he wanted to share with us, and it was a lot more than we anticipated. That area is not tapped out yet, but it occurs in a mountain range about 40 miles to the east, called the west, called the Humboldt Range. So you have the Fossil Hill member, which outcrops in two spots, and this one where it's not being where I don't work was the site of the 1905 Saurian expedition by the Berkeley Museum in California. They go out there, funded by Annie Alexander, who's a great woman in science, kind of a wealthy heiress that bankrolled and then provided a lot of written documentation for this. But they got a lot of these almost complete skeletons of these large Triassic ichthyosaurs going. But the Fossil Hill member, and one of the things that my team kind of aims to make a solid case for, is the best ichthyosaur locality in the world. We are up to about 11 species of ichthyosaur, and then the pistosaur. So 12 species in all, 11 species of ichthyosaur, making it tied for the most diverse in terms of species, but definitely the most diverse in terms of size diversity, in terms of like ecological guilds. So it's the only site known. It's the only glimpse we have this early on into what's going on the other side of the world. The Panthalassa as opposed to the Tethys. Every other mid-Triassic locality that's produced a lot of animals is in the Tethys, and ours is from the actual global ocean. We want to make the case that this is what the world's oceans look like, not just the Tethys. So
Strong argument. Okay.
there's my pitch for why my site is very cool, and hopefully that influences everybody's opinion of the Triassic as a whole.
Well,
So,
speaking
yeah,
speaking
go ahead.
of these massive and these really beautiful ichthyosaur skeletons, I think that's a good segue into the Jurassic, which is the more commonly known ichthyosaur period, I think.
Yeah, I talked a lot, so I'll let somebody else take the Jurassic away. I've got stuff to say about it, but
Okay,
um,
Jurassic.
yeah,
Well, I do want to open with like the Jurassic is kind of what got me into paleontology like as a child because it was all like Marianne based when I was 3. Like I am one of those people that decided what I wanted to do when I was 3 years old and then did it. So spoiler alert about my personality. Um, the diversity that we're starting to see like in the Jurassic, we're seeing like for people that have found this channel or are watching it, we know that like a big part of just like marine reptile lore that got eyes on it like originally in the mid like
not just marine reptile, but
yeah
like
yeah
large extinct reptiles generally.
yeah large extinct like reptiles. We're looking at some really cool things, just like how in like the Triassic, and then what like the most common example that we used in school, like the Cambrian was trying stuff out that didn't necessarily work very well and that we don't see today. A lot of that was going on in the larger animals that we're finding in the Jurassic like oceans to a point. I really do like Jurassic ichthyosaurs, though like my knowledge of them isn't as robust as I would like, but I do know quite a bit about plesiosaurs and pliosaurs. Pliosaurs is kind of where my main argument as far as like vertebrates are going to land, because pliosaurs are technically, when you boil it down, plesiosaurs, though They are different than the other short-necked plesiosaurs, which are polycotylids. Pliosaurs are croc-faced, but they have really like thick necks compared to short necks. So
And much larger. Like even like the bigger
exactly,
polycotyledon skulls are nothing compared to that.
exactly. The size of pliosaurs are insane. And specifically, what I really love is the teeth. If I'm going to convince you that this is like the coolest period of like marine faunal representation in the Mesozoic, I need you to look at the teeth that are coming out of the Jurassic, especially pliosaur teeth. I've handled some. I got to visit the Etches collection over in the Jurassic Coast, the C-Rex, as it were, as it's being called. Those teeth are insane. The faceting, the curvature. The curvature tells us, like in teeth, tells us really interesting and important things. These large pliosaurs were they were all getting very large. So they were all fighting. Some of their adaptations for their teeth are for infighting, which is a crazy cool like thing to do in my personal like opinion. I really like the Jurassic, how gnarly it was getting as far as like competition. I think we see the results of that in the Cretaceous. Knowing the most about like the Cretaceous in my research and publications, I do see the consequences of things that were occurring in the Jurassic really rearing their head in the Cretaceous. But pliosaurs are dope. I also am a paleopathologist, so a lot of what we know about what I study, which is osteoarthritis, comes from the Jurassic. We don't quite know why. There just seems to be a large influx of like rheumatological disorders in the Jurassic, but we have a lot of fossilized arthritis in pliosaurs and plesiosaurs. One of the largest pliosaurs ever known was studied by Dr. Judith Sassoon and has some, to me, beautiful pathologies, though she must have been in this critter must have been in a lot of pain because it was her jaw. She had an arthritic jaw. And so the Jurassic period has given us a huge step up also in like human medical study of understanding the presence of osteoarthritis in the fossil record. Thank you, Jurassic, for doing that to us. A lot of what we know about the continuance and development of OA can be like attributed down to our lens of just the really messed up pliosaurs in the Jurassic. That is my pitch. They're very diseased but very cool. To Brennan, who knows about the Shelly things.
Oh, the Shelly things.
Okay,
Yay.
real quick,
Guys, I
Mr.
gotta get
Rempert
Yeah.
has got a bull. But do you want to give us your ranking? How would you rank these as you understand them right now?
Ooh. Okay, let's see.
So I think we're gonna end up voting on this. So
I gotta say Cretaceous is first just because there's so much there. High diversity as far as just sharks, fish, mosasaurs, marine reptiles in general.
Ammonites.
The Cretaceous. Let's see. Second, that's a hard one. I like. I, I grew up on Walking with Dinosaurs. I gotta say Jurassic. Cruel
That's
Seas.
fair.
Sorry. Third's Triassic. So the one thing I will say, there's plenty of room for discovery in the Triassic because a lot of that's still being figured out. I think if this episode was to be had again 10 years from now,
no,
try
much
yeah.
less than 10 years from now.
Oh, well,
I've
soon.
got pictures
Yeah.
on my phone I cannot show people
Mhm.
in
Yeah.
in the search for the largest animal of all time.
Yeah. I think given the rate of discovery, Triassic's going to have a whole lot more going for it very soon.
Yeah.
All right. Hey, it was
Cool.
great talking to you all.
Thanks, Trevor.
You as
Appreciate it.
well.
Take care,
Good to meet
Trevor.
you.
Sorry, the library's closing.
Yeah, the Jurassic has diversity of ammonites. Personally, in my opinion, not as cool as the Cretaceous ones, because that's when you see the most crazy heteromorph shapes and whatever. There are a few Jurassic heteromorphs. One of my favorite ones is Spiroceras, whatever. It's got a thin shell. It's very narrow. It's kind of noodle-like, and it's a very loose whorl. So instead of having a tightly packed um, spiral shell like most, basic ammonites, it was uncoiled basically. So very curved looking. And we've got like common disc-shaped ammonites. Dactyliosaurus is one that got very fine ribs. Everyone knows that guy. It's very common on the market and in the UK. But my favorite ammonite from the Jurassic is the largest. Well, not the largest in the world. There are largest from the Cretaceous, but I think it's like the second or third largest, Titanites, and it can be found in the UK. But there's a specifically very special one found in my home province of BC, and it's up on a big mountain next to a coal mine. And back when it was found, the local miners would call it a truck tire, right? This massive truck tire made of stone sitting in the side of the mountain, and the people in town would hike up to it, and it would be an oddity. They've been doing it ever since. But that ammonite was eventually attributed to Titanites, which was first found in the UK, and their shell is enormous. Titanites could reach between 2 to 3 feet in diameter, and I've got a photo of myself sitting next to it as most of my profile images on social media, and it's huge. I could like fit inside the shell if I wanted to, or use it as a chair. And it lived in the late Jurassic, about 150 million years ago. But that's not the only thing that got big in the Jurassic. So usually when I think about crinoids,
Okay, real quick,
they're
why are ammonites cool? And
because they're
this is not a
they're
challenge.
squ
I'm asking like take
Like,
it
can
away.
you convince or
Wait,
like
no,
or
no, no,
something
no, no.
cool
I'm
about
getting.
them?
I'm
so
letting you convince everybody that ammonites are awesome, which they are. But we'd like to
you're
hear.
you're telling me a squid has its own mobile home that it can fill with gas or liquid to go up and down. It's got a little front door that it can close shut. And potentially they may have had webbing around their tentacles to encapsulate small prey, which I think is pretty neat. But my favorite part about ammonites is the shells are often found with circular holes, and some people believe those are limpet scars. So limpets go onto the shell and they carve a little hole with their radula. They eat it away. And then some researchers suggest those could be mosasaur teeth bite marks, right?
In the
And
Jurassic.
not in the Jurassic. No, 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 not
Ah,
in the Jurassic. I don't know of any Jurassic ammonites with bite marks, actually. I haven't looked into that. I've only researched the Cretaceous ones, so that would be cool to look into. But the Cretaceous ones, the original, I guess you could call it a holotype specimen of an ammonite being bit, has the mosasaur pterygoid teeth as well pressed into it. So it's not just random scarring in triangular shapes. It's, to me, very definitive proof that mosasaurs fed on ammonites, which I know doesn't make ammonites cool as on their own, but having this predator-prey association I think is pretty neat, along with them being like trailer park squid.
perfect. Great. All right. Now back to the other invertebrate you were getting ready to talk about.
Oh god, crinoids. They're very cool to me because in my head I view them as they're like starfish and sea urchins. They're echinoderms, but they have a plant-like lifestyle, where
Yes,
they're sessile. They've got a stalk, they've got a flower on the top, the calyx, the fingers, and they use those little arms as filter feeding appendages. So they'll scoop little food particles out of the water, bring it to their mouth, but usually they're quite small. You find crinoid fossils disarticulated for the most part. So you'll get these little like coin shaped,
popsicles.
Cheerio shaped fossils from their column. and
which are everywhere.
they're
Like rhinos
yeah,
are
they're
especially
common.
diverse, and they're like the primary reef builder. They're a primary reef builder for a lot of the Paleozoic, a lot of the mid to late Paleozoic. They get
Hmm.
hit pretty hard by the end Permian extinction event and never recover their old kind of ecosystem engineers that they were before. But in the Jurassic, is when we get a lot of the biggest ones.
Yes, the Cerocrinus are just insane.
You know
They can
why?
get up to 26 meters long, right?
Yeah. Do you know why?
Absolutely massive. The log, that big log, it's how long is it? 18 meters, the log, and
Right.
it's just covered in like hundreds of them. Huge specimen. Um,
So okay, so I got something to say on these logs. It's really
these logs.
really good
Okay.
for Jurassic stuff. For what makes the kind of Jurassic fossils cool. These logs, so like these logs happen today. Like, a log falls in the water and washes out to sea, and community sessile organisms like barnacles and oysters and stuff will grow and attach themselves to it and create these little micro habitats full of fish and other animals following this log around. Um, in the Jurassic, though, these modern logs have a not very long lifespan before they sink and they fall, and the little unique micro communities are gone. But they last for maybe 10 years. But during the Jurassic, uh, wood boring worms hadn't evolved yet, so that really increases the water in like the really the impermeability of the logs, so they take much longer to sink. And so we're talking about 5 to 10 times as much time is spent as these logs drifting around, vying for even larger and larger communities to build around them, like these giant 26 meter, no 20, how big?
18 meters? Yeah.
18 meter crinoids attached
Oh no,
to
the log is 18 meters. The crinoids are 26. Yeah.
26 meter crinoids hanging
Insane.
onto these logs that have been at sea for 100 years or so.
It's insane, truly. Um, there's also, I just learned this today, but I'm gonna act like I knew this all my life. Uh, Hermit crabs evolved during the Middle Jurassic period, and we know them as wearing gastropod shells, snail shells, and they've got that coiled, kind of hooked body that curves off to one side. Originally, they used ammonite shells. They evolved to use ammonite shells. During the Jurassic, gastropod shells weren't as hard as they were at the end Cretaceous, so we have hermit crabs evolving to use ammonite shells from the Middle Jurassic up till the end of the Cretaceous, when gastropods their shells thickened more due to the amount of durophagous vertebrates eating them, like sharks and mosasaurs and whatnot. And you see the switch from hermit crabs using ammonite shells to hermit crabs using gastropod shells. And it's much easier to drag a gastropod shell around because it's not as big, and the shape allows it to be dragged easier on the seafloor. So you see a transition right before the end of the Cretaceous, which I think is really cool. And there's these fossils. You find the hermit crab claws tucked up into the ammonite shell. It's pretty neat. Um, but there's also another cool crab-like critter from the Jurassic. And I mean, it's not specifically from the Jurassic. They actually might have come all the way from the Cambrian, which is my jam. I love the Cambrian, but it's inconclusive right now. They think it might be a part of the group. It might not be. There is a it's called uh Daliocaris ingens, and it's this funky looking shrimp-like thing. It's got this carapace on its back. It's got this huge like mono eye on the front of its head, and these alien-like arms. There's a movie. What's the what's the famous alien movie? Um, where they've got the tripod walkers and stuff.
War of the
War of the
Worlds.
Worlds.
Yes, this looks like a War of the Worlds alien with the big long arms dangling down and the big eyes. It's freaky. And what's crazy is it looks exactly like what you'd expect from the Cambrian period. Just a bizarre organism testing out weird adaptations. But these guys persisted, presumably past the Cambrian. We know they definitely appeared during the Ordovician, um, and onwards up until the Upper Cretaceous. So the fact that they could exist in an environment with other modern or what we assume to look modern invertebrates like shrimp. This guy would be hunting shrimp and other modern day looking critters, but it just looks so alien since it survived from a period of time where everything looked alien, right? Uh, so this guy's commonly found in the Jurassic, and I think that's pretty neat. I late surviving relic of the alien past, right?
Hmm.
Kind of sad they're
Well,
not around today, though. Wonder what they'd taste like. Probably not that good. They don't have that much flesh on them.
that's awesome.
So in
Yeah,
the
it's pretty sick.
Jurassic, I'm being a fish guy or a chondrichthyan guy. The most famous fish would be a bony fish, would be Leeds ichthyes from the Jurassic, that giant filter feeder. But as far as chondrichthyans go, I think that that stuff, albeit I'm biased, is more interesting. Um, that's when we start seeing our first like crown group sharks and rays as well. Your hybodonts are still going, strong in the Jurassic, but we see our first rays, or at least our first definitive rays. Like we look at them, we know, yeah, that's a ray. We see the same thing with some crown group sharks. So we see our cow sharks for the first time, the hexanchoforms. We see that with our horn sharks, heterodontiforms, angel sharks, so on. So it's really cool. We start seeing our some sharks that we could like recognize as, yeah, that's similar to what we have now. So that's really interesting. But we also see some oddball stuff that really are unique. One of them being Squala raha, which is a chimeriform. So these are closely related to ratfish that we have today, except they evolved a ray-like flattened benthic body plan, which is really unusual. We also see the enigmatic Astenoselacae, which has almost like a goblin shark style extended rostrum. So there's a bunch of weird, wacky stuff going on in the Jurassic within the Chondrichthyan world, just as much as there's some more classic sharks. And we should also talk about the formations that these are found in. With the Jurassic, we have the Holzmaden and
That's
we
fine.
have the Solnhofen limestone, which both have really, really incredible articulated fossils. Like Solnhofen, we see multiple different shark taxa fossilized there, like completely preserved articulated remains of like the cow sharks, the horn sharks, this early tentative lamniform called Paleocarcharius, which has a benthic style body plan, but histologically and morphologically, the teeth more so resemble what we see with lamniforms than with anything else. They have a osteodentine tooth design, which is something that we only really know from true sharks to be within the order lamniforms, the mackerel sharks. So we see these really nice articulated fossils from there. Um, the Posidonia shale in Holmesmaden, we see a lot of the ichthyosaurs that I'm sure Cole will elaborate on. I've seen some really cool hybridont material from there too. Just a whole bunch of cool stuff in the Jurassic preservationally.
Yeah. So zooming out a bit on the Jurassic. So all of these Jurassic assemblages, going in coming out of the Triassic and going into the Jurassic, there's a mass extinction event. Obviously, as I'm sure anybody who's found this channel probably knows. It's not the biggest one ever, but it is substantial, and it knocks out a lot of older Triassic diversity. The ichthyosaurs, and especially are their heyday is in the Triassic. That's when they're the most diverse. That's when their sizes are ranging from this big to, you know, blue, blue whale size and potentially larger. Um, but coming out of this extinction event, the ichthyosaur diversity is bottlenecked, and you have the proliferation of all these other forms that probably are originating in the very end Triassic, but plesiosaurs and then eventually pliosaurs themselves. So um, starting and the only ichthyosaurs left are these kind of like more compact, like all the various like anguilliform eel-like ichthyosaurs are gone. All the ichthyosaurs coming that are surviving are very compact, mostly. Um, but they do still have some interesting Jurassic diversity as well. Ichthyosaurus communis, obviously, like the stereotypical ichthyosaurs known from Lyme Regis and the blue lias unit. But you also have stuff like the Excalibosaurus and Urinosaurus, which are these ichthyosaurs that evolved to be exactly like swordfish. Very long, raw, upper parts of the cranium, but their lower jaw remains short, exactly like a swordfish. We interpret a swordfish lifestyle from them. Those guys are all living in the early Jurassic and going into the are kind of extinct by the late Jurassic. You also have Dinosaurs, which are these orca-sized ichthyosaurs, and probably orca-sized and maybe even larger that would have been probably the apex predators of their day and are a very serious contender for the most formidable predator of the Jurassic period. But as the Jurassic goes on, the pliosaurs don't really evolve in the early Jurassic. They've got their precursors around. The earliest pliosaurs still have the very long plesiosaur necks, but going for the first like these huge crocodile giant, you know, 10 foot, 6 to 10 foot long pliosaur skulls. Those don't show up till like well into the mid-Jurassic. So within the Jurassic, you're seeing kind of the shift from the ichthyosaurs and the Remilosaurs, which are these, medium-necked plesiosaurs. And then towards the end of the Jurassic, the Remilosaurs are gone, and you have only the very long-necked ones and the short-necked, big mouth pliosaurs. So you have this really cool kind of change within the Jurassic, and all of these Jurassic heavy these Jurassic communities with lots of fossil assemblages. All of them are coming out of Europe. Specific taxa are known from all around the world, but you don't get anything like these giant assemblages producing dozens of taxa except anywhere but Europe. The North America, for example, has the Sundance Formation, which was like in Wyoming, where we get a few. We have like Megalosaurus as a pliosaur and Baptanodon as an ichthyosaur, but it's nothing compared to these giant European assemblages. So in Europe is a flooded as a continent. It's rendered as just islands of land and is the confluence between the Baltic Sea Passage, the Tethys, which is coming, kind of splitting Africa and Asia apart, and then the Proto-Atlantic is meeting in these kind of European archipelagos and creating these rich assemblages throughout the entire Jurassic. In the early Jurassic, you have the blue lias and the blue lias where Mary Anning did her work. The Oxford clay and the Posidonia shale, which is the Oldsmon stuff. Um, and then finally the Oxford clay, the Charmouth mudstone, the Kimmeridge clay. You even got a very good assemblage up in the high Arctic in the island of Svalbard, Spitsbergen, which has got kind of a less diverse assemblage of marine reptiles, and that's probably because like there's no, for example, marine crocodiles living in these kind of very high latitude spots. And that's probably because it's too cold for them. They're still warm-blooded, and they can't survive in these kind of colder, entirely cephalopod-based ecosystems full of like, diving ichthyosaurs like Ophthalmosaurus and stuff. But so something very, very cool that I learned about this shallow seas and archipelagos is that the primary reef builders at this time are not anything that we traditionally associate with reef building today. They are the hectanolitid sponges, which are completely silica-based sponges, and they form these they're the primary rebuilders of the Jurassic, and they form these giant, and I mean giant structures of silica crystals that form up these sponge skeletons. And these sponges can only live in they don't because they're sponges, because they're not corals. Corals need to photosynthesize. They have a symbiotic relationship with algae, with photosynthetic microorganisms, plankton. These sponges don't have that. They are entirely, secondary consumers, and they're entirely consumers, so they don't require sunlight, but they do require still water. So they can form at any depth, just so long as the water is still. And in these deeper-ish regions of this European archipelago, they form these enormous biotherms of, huge altars of silica crystals, um, that are 7,000 kilometers long and form, as we know it, the largest biological structures known on the planet in its entire history. So I think that's pretty cool, and I think that's a lot going for the Jurassic's favor.
Yeah. Yeah. So I think from there, that's a good place for us to go into the final period of the Mesozoic, the Cretaceous.
Yay.
Real quick, um, most Jurassic long-necked plesiosaurs are quite small, like seal size, biggest are 20-footers. But I find one in my research that was way bigger than I was expecting to be. There was a cryptoclydid. It's called Muranosaurus, the eel lizard. It's from England, and they thought it was an elasmosaur at first because it was so goddamn big.
Yeah.
So there was a giant cryptoclydid Jurassic plesiosaur known, and I think that kind of rounds out Jurassic diversity in a very nice way. So, anyways, done with the Jurassic. I've exhausted my notes on it.
So Bethany, tell us some about the Cretaceous plesiosaurs.
Okay. Cretaceous plesiosaurs. I will launch into mosasaurs because
Ooh,
that's
okay, I forgot one more thing. One more thing that I have to say.
okay.
I'm sorry,
I'm
Ben.
gonna
This is
eat
going to
my
make
ice cream while you do it.
your life very hard as an editor. But and this is especially important to Brennan. These giant hexactylid sponge reefs, we thought were just something that would solely existed in the past until in the last 30 years they found a living glass. Hexactylinids are called the glass sponges, a living glass sponge reef right off the coast, British Columbia.
Hmm. It's incredible.
Real fossil ecosystem.
Hmm.
It's a kind that exists nowhere else on Earth, and only so far back in time as the Jurassic period. So, okay. Promise I'm done now.
Cretaceous. This is now I have my boxing gloves. I actually know
Ding, ding,
my
ding.
stuff. First off, to lay the foundation of anything going forward, the Cretaceous, a good way to look at it is that, as the last part of the Mesozoic, this is what was always developing. And this is the last kind of view that we get of some of these lineages of animals, of what they became. So their ultimate forms for how we look at them as paleontologists and, just as animal fans in general. We have this, speculative evolution as a whole, like another field, but what we get in the Cretaceous is the result of the toil and trouble of the Triassic and of the Jurassic. You get the Cretaceous. For the Cretaceous, it was great to be a squamate, man. Like, you had the best time if you were lizardy and in the Cretaceous. When we're looking at our plesiosaurs, that's when, as Cole mentioned, like the size.
Plesiosaurs are not squamates.
Well, yes. Well, I know.
Well,
shifting. Oh
you
yeah,
know, but
yes, yes,
the dear viewer
yes.
might.
That was not a good shift
Yeah,
on my point.
yeah.
Circling back to then like tell me about Cretaceous plesiosaurs. So my transition being there. Size is something that, you know, tells us a lot about an animal's life, no matter where and when. But with the plesiosaurs, when we start seeing a shift in size, we also, interestingly enough, see it in at least some like snapshots in the literature, their increased size having to do with perhaps the increased like temperatures. And when we look in China, there's a really cool example in China for our plesiosaurs. We unfortunately get a lot of plesiosaurs named off of teeth. Not the best to name like an animal that's not a mammals. You can fight for naming them off of teeth, but with plesiosaurs, you know, whatever. But the spread of plesiosaur teeth, it was originally documented in China, but then they started to do it some places in North America. Based on plesiosaur shed teeth, we've been able to kind of extrapolate migratory patterns in fish, which I think is like really crazy cool. Just based on teeth that were being dropped because it seems to be in a very like following the pattern that modern day fish take, and just the distribution of certain species of fossil fish that we see. They will be like corresponding pockets of plesiosaur teeth. That's a really cool thing to look at when we are trying to figure out where we are in time during like field work. A great thing to find is what's called an index fossil. So when you find inverts on your site, you're like, yes, cool. We can figure out kind of where we are with our index fossil. Well, sometimes plesiosaur teeth can be used as index fossils, which is rather radical. Which is kind of one of the only other examples of like a large
Vertebrates in general being
yes,
indexed.
being index fossils. The only other large like vertebrate that I can think of as an index fossil happens to be Myosaura. And that's just because there has been a lot of work done, not
Myosaur?
like Myosaura, yeah, for like dinosaurs.
Oh, okay. Yeah,
Myosaura is one of the only examples that, at least like in my like view, that's I did my research internship in the two medicine formations. So Myosaur was literally something I stared at every single day of my life for 4 months. But that the only reason that kind of animal is used as an index fossil is just because that it is just the preservation of two medicine. Great. You also get a lot of Myosaur because it was a nesting area. But the fact that you can just almost universally use different species of plesiosaur and their teeth as index fossils for like these fish. You can use fish as index fossils. But not great. But teeth from a large vertebrate in general, as an index fossil from the Cretaceous. Take that. Yay Cretaceous. Large, getting large. But then I have to mention mosasaurs. I got to do it. Mosasaurs are the pinnacle of what nature was trying to do in our like secondarily aquatic animals. Just when we look at the different families of mosasaurs, we can see that there is a variety of size, but not necessarily locality. And what I mean by that is that it can be rather unusual for an ecosystem to host more than one animal of a specific size class. So a kind of more familiar example that we see in modern day, especially in places like Texas and California, are female mountain lions. Female mountain lions require a large amount of space for themselves in their territory. They are the largest predators in that area. This is their space. They don't take kindly when smaller like animals such as bobcats enter their territory if they're around. Doesn't happen very often. Mosasaurs of equal size are inhabiting these same localities. The adaptations of mosasaurs are so specific, such as like our globidens, and then we have like cleidaces, all of these, it comes down to teeth and the way that their jaws lock. Of course, there is some like flipper diversity, but really, mosasaurs diversified in such an incredible way that they were not very much overlapping, at least species to like species, overlapping in resource exhaustion. So a super large globidens chilling out, just eating all of its fun cephalopods. If there was a non-cephalopod consuming mosasaur of its exact same size or bigger, not a problem. We see a lot of infighting, though, of like tylosaurians love to duke it out. That they love to attack each other, but the evidence of tylosaurs attacking other equally sized mosasaurs, there's some
There
information.
were no equally sized mosasaurs with the tilosaurs.
Correct.
Yeah.
Correct. There were not. I'm going to say that information is not there because that is not a problem that they had. When mosasaurs kind of cooked themselves was getting too specific. But it also worked for their, like, it was advantageous sometimes, but mosasaurs, there are lineages that just went because they were really too endemic. Endemacy is a problem. An endemic animal, for those who don't know, is a great example of an endemic animal are kangaroos, like on a large scale, as we think of kangaroos being over there in Australia. There are more extreme examples of endemacy, such as the devil's hole pupfish. There's like
I was there a couple months ago.
Okay, Brendan and I love the
Mhm.
devil's hole. We watched an entire like documentary on it like last week, 2 weeks ago.
A couple weeks ago,
A
yeah.
couple weeks ago, we love the pupfish.
I didn't go to Devil's Hole, but
Big
I saw the
fans.
Armagosa Springs pupfish because like Devil's Hole is like you can't get that close to it. You
You
can't
can't
get
get
close
that
to
close to it
actually,
because it's
and you
yes.
can't actually see like the
Yes.
Devil's Hole pupfish in the. So it was like, and it was way out of the way. So it was
Yeah, the
like, yeah,
Amargosa
this is
pupfish is
kind of a waste of time. I was with my cousin, but like the Armagosa Springs, which are almost as endemic, are
correct.
in. You can get right up with them. You can stick your
That
finger.
is crazy.
I mean, you could. You shouldn't, but you could.
You could, but you shouldn't. Yes. Like so these endemic animals are found in only one pond. Not only in one pond for the devil's hole pupfish, one shelf in this one pond, in this about, what is it, 13 by 6 rock shelf. Um, that is how specific this one animal's like endemic lifestyle is. They need to have the exact temperature, the exact bacteria count, and the exact sunlight just from that one shelf. Well, with mosasaurs, because there was a lot of diversity in like the prey field, they were really like, okay, there's a lot, like nature was like, there's a lot of this. You, mosasaur, can have this one. As much as I love mosasaurs with my entire heart, there was kind of a decline there. Like the tylosaurs, my babies, didn't like.
We're doing great at the end.
Yeah.
Well, I mean, that's the thing with squamates. They can't even survive a one mass extinction event.
You know what? Them fighting words. Um, and you're not exactly invalid with that with that view. The Cretaceous as a large scale, because remember everyone that's tuning in that this is our marine like faunal assemblage like debate funness. A lot of what the standard population knows about paleontology does come from a lot of interest in really famous Cretaceous dinosaurs. That is like how
And
how it goes.
and a lot of like mosasaurs are the it thing for marine reptiles right now. Like
They
they've
are
got
they are the it thing
way
for
more kind of
marine reptiles.
bogus than most other groups.
Correct. And I think that from just a American person's point of view, especially a Texan, the fact that mosasaurs very, very likely, as far as the data that we have collected and are still collecting, and that should be published soon, Texas is the birthplace of mosasaurs. Yay. They also so rapidly diversified and grew. It's crazy. The first like mosasaurs that are mosasaurs and not transitional species, going from A to A, not mosasaurs, just like our weird swimmy lizards, and then our huge swimmy defined lizards being mosasaurs. Mosasaurs could be, let's see, like this big, a little off screen, to our big Tylosaurus prorigor, where we're pushing like bus size people, but that happened in a very geologically speaking short time period.
How short?
Well, a blink in the
What,
geologic
like 10 million years, 15 million years?
10. Yeah. For the whole expanse of things, yes, but the
Source did it
rapid
in 5.
the rapid size like growth and the adaptations as far as mastication methods, because not only were the teeth defined, but also we can look at different jaw morphology to see how different species were using the same base plan of their teeth to eat. We see like wear patterns in rooted teeth, but also again arthritis, looking at injuries or just natural wear in the bone. And I'm going to just hand it over to Brennan, or I'm going to talk for
Real quick, the something to keep in mind about the Cretaceous, that the Cretaceous is 80 million years long. It's by far the longest geologic period of the Phanerozoic time of the animals. It's like almost twice the size of like the standard one.
yes.
And within the Cretaceous, you really have two different assemblages going on. The early part of the Cretaceous is very, very, very similar to the late Jurassic. And then there's a big faunal turnover right smack in the middle. And out of this faunal turnover, you lose the ichthyosaurs and the plesiosaurs and the marine crocodiles, for that matter, which we should talk more about, but nobody here knows anything about them. Um, and coming out of that, you lose the ichthyosaurs and plesiosaurs, and out of that come the mosasaurs. So the Cretaceous has really, really like these two big grand diversity schemes that contain within itself. So, anyways, just wanted to say that.
Yeah.
Brandon, tell us about heteromorph ammonites,
Well,
dog.
I wanted to elaborate more on the diversity of mosasaurs at the end of the Cretaceous, because that's my field of study. I have several publications on mosasaurs from the very end of the Cretaceous, from the Maastrichtian. And when I say they diversified, I mean they just exploded. And we're talking the end of the mosasaur reign, the very end of the Cretaceous, end of everything. The last hurrah is when mosasaurs truly exploded in diversity. We've got fossil sites that host up to around 25 to 30 different species of these macro predators, which is nuts. This shouldn't even be possible. We're finding just massive mosasaurs, 5, 6 apex predators, anywhere between 10 to 12 meters long, existing in the same environment at the same time. It's insane. It's truly incredible. Most of my work is based out of Morocco, where these specimens are found, and some of the mosasaurs are not endemic to this region. They come from other parts of the world, and what it's hypothesized is Morocco during the time had seasonal upwelling, so nutrients from deep water would be washed up, and prey items such as fish and ammonites, they would come in, and mosasaurs would migrate to Morocco to feed during these seasonal upwellings. And that's why you get so many different species in one place. But what helped them not compete, not overlap, they all had different teeth. This is a point in time where mosasaurs were more like sharks in teeth diversity, where you could actually identify down to a species level with a single tooth because their feeding niche guilds were just so niche, right? Um, so we've got two species of mosasaur. We've got all sorts of globidens and crushing shelled mosasaurs. We've got Prognathodon, Thalassatitan. We've got really tiny mosasaurs like 2 meter long Crinodens, Xenodens. Um, and we've got these squid and fish eating mosasaurs like Pleurodens and Halosaurus with little hook jaws or teeth, and big cutting teeth mosasaurs like Hanosaurus and Mosasaurus, all existing in one place. And we find their skeletons, their teeth, um, in the sediment together. So we know they weren't coming here at different points in time. They were all here at the same place at the same time. It blows my mind every time I think about like what the environment must have looked like with all these massive predators just swimming around, feeding on different things, right? Um, with their unique teeth. So they definitely took it to a very special level, but this was right before the asteroid hit. And I can only imagine what they would have done moving forward if they didn't go extinct in terms of like teeth diversity. So they're definitely the pinnacle of evolution. In my opinion, mosasaurs are pretty sick.
Yeah.
uh,
And let's
Ammonites are too.
you want to talk about the ammonites before I go on with sharks?
Yes. So ammonites also diversified during the Cretaceous. Majorly, they exploded and radiated in all forms and shapes. We've got crazy, they call them heteromorph ammonites. So instead of the typical spiral shell that we're used to, we have any shape imaginable, any musical instrument, any just amorphous blob
Office.
of shell in a
Clarinet.
clump, right? My favorite heteromorph ammonite is a 2 meter long paperclip. So this guy's called Diplomosaurus. I
So
have a
called.
personal history with Diplomosaurus. When I was 7, I joined the Vancouver Paleontological Society, and their first meeting that I attended was on a specimen of Diplomosaurus that was found in association with a toilet seat shaped fossil. And they're trying to figure out if this toilet seat was a part of the shell on the front, kind of like a flotation device. Um, and the whole talk, they were just saying, does it hinge on the outside of the shell? Is it even connected? Is it part of it? I thought that was the coolest thing ever. And ever since seeing that presentation, I wanted to find my own Diplomosaurus, my own 2 meter long paperclip, right? It just baffled me. Um, so they could be found in Antarctica, Montana, or this tiny little island, Hornby Island, off the coast of Vancouver Island. And I was like, okay, how am I gonna get to Hornby? A few years later, we do a field trip out there, spend the whole day digging, and I find this huge round kind of donut shaped rock, and I turn it over and I see those iconic ammonite ridges, those ribbings along the shell that give it support, and I knew immediately this is a
Suture patterns.
massive cross section of a Diplomosaurus. It was like the best day ever. I was like, finally found it. It was just a piece. It wasn't the whole thing, of course, but that was enough for me. So Diplomosaurus has a special place in my heart, and it's one of my favorite fossils. Very cool.
So we
Mhm.
love ammonites here.
Yes, big Ammonite
I'm not
stands.
being sarcastic. I'm being like ironically unironic.
Mhm.
You should see my collection of parasitized, beautiful ammonites from Lyme Regis.
You
They're
see my collection of ammonites I tripped over, or ammonoids in Fossil Hill.
just like a bucket that's just labeled like bad
Yeah.
ammonite.
Yeah, they're all like very like compressed and stuff. There are some 3D ammonite horizons which are going to be very useful for the biostrat we want to do for our big geology paper that I'm collaborating on. But um
That's so good. I love ammonites
and
as
ammonoids. So
oh,
to be clear,
ammonoids.
Oh
and
yeah,
I
yeah,
want to make this
ammonoids.
I want to make this ultra clear to everybody, and the reasons will become clear in just a second. Ammonites only exist in the Jurassic and the Cretaceous. Things exactly like ammonites, but with less complex. So ammonites, ammonoids, these coiled nautilus things, um, they date all the way back to the Ordovician. Very, very old guild clade. But they're determined. increasingly more and more complex through time in terms of their suture patterns. So as the ammonite grows, it secretes a new layer of calcium carbonate to form its shell, and this layer, the bound the pattern the little boundaries between each chamber is called a suture pattern. And in the most primitive ammonoids, nautiloids, they're straight lines. But as you go further and further in time, they get more and more complex. And the ammonites are any ammonoid with an ammonitic suture pattern, which are the maximally complex, like mathematically looking kind of dendritic. But this suture pattern doesn't appear till the Jurassic. And I was docked a letter grade on my ammonite functional morphology paper for my invertebrate paleontology class because I used ammonite colloquially to mean ammonoids as a whole. So I want to make that clear to everybody so that nobody makes the same mistake I did.
Do better in school than college.
There's also the
I'm
gigantic
filled with
Paraprosia too in the Cretaceous.
yeah.
Mhm.
Yeah, ammonite that you would lose a fight with. Like I like how I ultimately categorize animals in my head is animals I would win a fight against and animals I would lose a fight against. And so like what?
Don't start this battle with me because I have like a very base argument about why I would win against one velociraptor.
Yeah, exactly. Yeah, I mean, a velociraptor is the size of a fox. You kick the thing and it's like halfway
Kick
across
the
the
thing,
room.
yeah, but if it comes at you from behind, like I hope you enjoy
Who
the
cares?
podcast.
Is a fox going to come at you from
No,
behind and like take you out?
as someone who has
Are
fought a
you a
wild turkey,
3-year-old?
as someone who has fought a wild turkey, I can tell
Oh,
you they are
I
deceptive.
fought a flamingo and I won.
I won
You
against a
know, I
turkey.
was at SeaWorld and I was 15 and I grabbed.
I was
Oh
11
my God.
and it was a singular wild turkey who had one eye and had seen some things.
Well, you're just not from the streets, okay? Where
Yeah.
we fight avian dinosaurs around here. But um, sorry, this pretty stupid tangent is
Do better at school,
like
Nicole.
every once in a while, animals that are very cool, but you could take in a fight, produce an animal that is very cool and you couldn't take in a fight. And this is a rare case of that happening with invertebrates. So is
It's more like a
a silly
skill issue.
personal anecdote I have for this.
It's like a skill issue, not like a generalization.
Are you telling me that you're gonna like take on like a
I'm not
6 foot? Okay.
Well, speaking of animals you probably wouldn't win in a fight against, the Cretaceous has some pretty
ever made
I,
them.
the Cretaceous has some pretty iconic bony fish like Zephactinus. No way on Earth would we win in a fight with those.
I'm built different.
Yeah,
Basically,
wrong.
these are
If you think you can win, you
these are
go
20-foot
wrong.
long bony fish that are notorious for dying from swallowing food that's too big for itself.
That's person sized, by the way.
Yeah. So, yeah, so Zephactinus, those are pretty cool. There's also some large filter feeders, albeit not the same sizes like the Jurassic's lead ichthyes. There's Bonerichthyes in the US in the Western Interior Seaway.
Chuck
Um,
Bonner.
yeah, my favorite stuff, the sharks. The Cretaceous is really like, while you guys said it's a mosasaur heyday, it's also a
Well,
shark heyday.
half the Cretaceous is the Mosasaur heyday. The other
I would
half is
say more than half is a shark
I would
heyday.
say more than half as well.
right. Well, I said Mosasaurs, not sharks.
Yeah, sharks I think is a bit more. So in the early Cretaceous, you start seeing some more crown group sharks start emerging. You see like your bramble sharks and your squaliforms, so your dogfish sharks. Um, but the main shark that I think really defines the Cretaceous would be the lamniforms. So like I said before, in the Jurassic, we really only see the benthic Paleocarcharias, whereas in the Cretaceous, from the early Cretaceous onwards, you really start seeing an explosion of diversity with lamniforms, some of them reaching really large sizes and being direct competition and even predators to things such as plesiosaurs and eventually mosasaurs. Some of the most iconic ones would be Cretoxyrhina. That was a really fast, active, regionally endothermic shark that had a pretty large geographic and geologic distribution to it. Other really large Cretaceous macropredatory sharks would be like Cardobiodon, Duardius, Cretotus. There's a whole bunch of them, and they really do experience a great amount of diversity in the Cretaceous, and it really isn't until the very, very end of the Cretaceous that we start seeing those large sharks, the large lamniforms, start dwindling in, I guess, succession to the mosasaurs diversity. But yeah, you see Cretaxurina up until the Campanian, and then another really cool shark that made it into the Campanian before going extinct was Tychodus, which is a durophagous, so it was like crushing shells, lamniform that reached well over 30 feet long, which is a massive, massive shark that people used to believe was like a slow benthic, clam eater. But these were active macropredatory sharks that were eating like sea turtles, ammonites. Like they were pursuit predators, which was
Captain
insane.
Crunch.
Yeah. Yeah.
Yeah.
So, and they had an extreme level of diversity too, Tychodus. So those were awesome. We see Squalocorax, Cretalomna. Cretalomna, for those
Corax,
who don't know.
Corax
What?
gang, Corax gang.
Yeah. Yeah, so Cretalomna, for those that don't know, is the ancestral genus. It's paraphyletic that basically gave rise to the megalodon lineage. So we see megalodon's humble beginnings in the Cretaceous with Cretalomna. Um, you see some really cool other sharks in the Cretaceous, like great white-sized frill sharks in Hornby Island, Diceus, for example. Um, yeah, it's just a great time. It was a great time to be a shark until mosasaurs got really big, and then it was less great of a time.
Sharks just keep getting kicked around by marine tetrapods. I'm sorry to say it, but like, like sharks are like, man, the Eocene's really cool. Wait, what's that?
Yeah, but
Right?
there is a period of time where Cretaxurina, they were eating a lot of the mosasaurs.
I'll give
No,
you
they were scavenging their dead bodies.
No,
That's-
these were active predators. These were one of the fastest sharks of all time. They're growing.
active, but not successful.
I don't know, I'm Team Shark all the way. These things
we
were
know,
they
we
had
know.
such a wide range. But anyways,
Really
that's I
cool.
guess a debate for another episode where we've done sharks versus mosasaurs in the past. But right now they're fighting in tandem against the Jurassic and Triassic.
Right.
No, the
So if
sharks
we
of the
don't have
Cretaceous.
anything else in the
Okay, so an animal that I love from the Cretaceous, maybe my favorite Cretaceous marine reptile, besides the ichthyosaur, because gotta gotta stick with my people, is the Aristonectes.
You would be
The
correct.
the what?
I said you would be correct. That's a good
Yeah,
choice.
Aristonectes is a plesiosaur. So going into the Cretaceous, you've got different plesiosaurs. The cryptochlidids. Most of these Jurassic plesiosaurs, their necks aren't super long. They're long, but they're not the super long, like 20-foot necks that when you think plesiosaur, you think most of these Jurassic plesiosaurs they're like medium neck plesiosaurs, cryptochlidids especially. There are a few exceptions to this, of course, but um, then going into the Cretaceous, you have the Elasmosaurs, which are like take over in terms of like total plesiosaur diversity, alongside the pliosaurs and the polycotylids. Um, and all these Elasmosaurs have very, very long necks, very long, longest necks ever, the longest necks ever. Um, but there are some elasmosaurids known from the southern hemisphere from the very end of the Cretaceous of these elasmosaurs that are kind of getting shorter necks, but very, very huge body. Still not very short necks, but not the snake necks from before, and huge bodies. And these are the biggest long neck plesiosaurs known. These aristonectines, and they were probably filter feeders as well, and made probably the biggest, heaviest. These big bodies are very massive. These Antarctic humongous sieve feeding. They had these, kind of a trap structure in their teeth. They could go into the substrate in the soil and filter out microorganisms. I think they're like one of the most interesting features in like this end Cretaceous Maastrichtian diversity, and I think they're really awesome.
They
And
have rib cages too. You didn't like the like splay of their rib
tell
cages.
me about it. I don't know much about it.
Okay,
I just read the Wikipedia page about it.
yeah. So the splay of their rib cages is like when you think of like a like thoracic cage, it's very like nice and like fun. Think more like boomerang, like weird, not a cool, gentle like taper, just kind of like a like abrupt, almost like look squish, but not. They just
Hmm.
have really interesting like if you just look, there's nothing like no like mechanism like for it. They just have like really interesting rib cages.
Cool.
Yeah, just one of those things like you notice when like you look in children's picture books that Ceratosaurus always looks angry, but that's just because like of the brow horn. But now every time you look at a children's picture book that has Ceratosaurus in it, you'll be like, yeah,
He's angry because he just recently got bullied out of his niche by allosaurs.
yeah, he's just like, guys, it's not fair. Yep, that's all
We
it
hate
was.
we hate Ceratosaurus. Yes. You heard it here. I speak for all of us when I say that Ceratosaurus is worse than Allosaurus and got what was coming to him. So, anyways, um, uh, okay. I went on a long tangent about this on our Western Tier Seaway episode about polycotylids. Should I go back into that here? Does
Sure.
everybody know about polycotylids and the fact that uh, so polycotylids, and this probably has larger implications for plesiosaurs generally. Okay, so we used to think that plesiosaurs hauled their large bodies onto land to lay their eggs, because they're reptiles, they lay eggs, everybody knows that. But no plesiosaur eggs were known, and it eventually we kind of figured out they were probably too big to do such a thing. And then we actually discovered evidence of a pregnant plesiosaur, a polycotylid, a big polycotylid, big 20-foot polycotylus proper. It's currently on display at the LA County Museum. I saw it last summer, and it had an embryo in it. That kind of launched a people start paying more attention to young plesiosaur histology and stuff. And this is in a plesiosaur histology paper, and way to bury the lead on this. But because it's not in much of the actual title of the paper itself, but it found that young plesiosaurs were putting on via bone histology, were putting on upwards of 75% of their weight in a single year, which is completely not feasible without parental care. And that has very strong implications towards these plesiosaurs are only giving birth to these polycotylids are only giving birth to one giant baby, and then caring for them with investing into their offspring afterwards. And the only other animals that do that such a thing today are like whales, elephants, and humans. And all of these animals have very, very strong and complex social lives as a direct consequence of this parental investment in their young. And I think that is well, while we can't know for sure, strongly suggests that plesiosaurs had some dynamic social relationships, adding another layer of kind of like very interesting, complex, and I think beautiful behavior to the life in these Mesozoic oceans.
Yeah. So with that, I think that we can start trying to rank these periods. So we have Trevor's votes for the Cretaceous, then the Jurassic, then the Triassic. What are you guys thinking?
Okay, so I'm just going to start us off here. I'm just going to start us off, and I think that this is going to win out. I think so.
Uh-huh.
Number one, Cretaceous. Number two, Triassic. Number three, Jurassic.
I will give
Does
you
anybody
that.
disagree?
I don't disagree.
I would agree with that too.
That's literally what I had.
It's
So,
I
and my reasoning behind this is that the Triassic, I think, goes toe to toe with any of these other fossil assemblages that we have. I maintain strongly that the Triassic is just as like an incredible time. Like it's not just a precursor. It's not just like the lead up to something grander happening. It is as just as um, dynamic and interesting and spectacular as any of the things that come after it. But with the Cretaceous, you're dealing with one diversity amongst these marine reptile clades that the Triassic is close but can't really compete with, even if they do get bigger. And two, you're getting a two for one. You get everything cool from the Jurassic and this late Cretaceous mosasaur, elasmosaur, Zephactinus, giant sharks, polygotylids, all that stuff going on in the latter half of the Cretaceous. So you're getting a two for one. So I think the Cretaceous just had because the thing is so long. If you were to split the Cretaceous in half, I think there'd be more interesting arguments to be had. But because the Cretaceous is so long, I think the Cretaceous has just got to win. And then Triassic is number two. And then the Jurassic, while cool, and I learned a lot about it for my research for this, is just everything happening there, except for those cool glass sponge biotherms, is also happening in the early Cretaceous.
So yeah, do you guys
Uh,
agree with our picks of Cretaceous, then Triassic, then Jurassic? Let us know in the comments, and please don't forget to like, subscribe, hit that notification bell, and we'll catch you guys next
and
time.
yeah.
if you guys are new to paleontology, you're finding this channel for whatever reason. Maybe I recommended it to you in person, and we're talking about stuff because we're not this channel is very like we talk a lot towards people who know a lot about paleo. There's something we mention, and you guys don't really know what we're talking about in terms of like what is a like the time scale. What is the
yeah.
Triassic versus the Jurassic? Please ask a question, and we will personally answer those questions in the comment section.